Hey, what's up, guys? This video is going to be for the Gatorade lab, where we're going to use Beer's law to find the concentration of an unknown solution. So this is some Gatorade. We know what it is, but we don't know what its concentration is. And so our goal is to find the concentration, the molarity of this unknown Gatorade. And the way we're going to do this is by using Beer's law. So this is a colorimeter. And what this does is it has a light on one side, and it shines over to a sensor on the other side. And there's a little place inside where we can put a sample, and so this is just a sample of plain water. And so when you put a sample of plain water in, the light shines through, and all of it is passing through and is detected on the other side. But when we put in a sample of something like this Gatorade, we put in a sample of the Gatorade, which has some color to it, then it's going to absorb some of the light. So I'm going to take a sample of the Gatorade. This is the unknown Gatorade. We don't know what its concentration is. And if we put this into our colorimeter and we turn it on, it's going to shine the light through, and some of that light's going to be absorbed. And if we measure how much light's absorbed, we can use that to find the molarity. So what we need to do in this lab is make a series of standard solutions, solutions that we know the concentration of, and then we're going to compare those to our unknown, and then we can figure out the molarity that way. All right, so the way this works, we're going to use a volumetric flask. This is a 100 milliliter volumetric flask. It's an accurate way to, an accurate container to mix up a solution in. And so I'm going to put some water in here to start out. So I'm putting water in. And I'm not going to fill it all the way to 100 milliliters. I'm going to fill it about halfway. I don't want to fill it all the way because then there wouldn't be any space for the Gatorade. This is some Gatorade powder that I weighed out earlier. This is 16.33 grams of Gatorade. So 16.33 grams of Gatorade. We're going to pretend today that Gatorade is all sugar. It's not a bad assumption. Gatorade is mostly sugar. There's some other stuff, some flavoring and some salt in there, but it's mostly sugar. And to make our calculations possible for the molarity, we're going to calculate the molarity of the sugar. The food coloring is obviously what gives it its color and what makes it possible to use Beer's law, but we're going to pretend that all 16.33 grams of Gatorade that I just put in there is just all sugar. All right, so I'm going to put the top on, and I'm going to shake this up a little bit to get it to dissolve. So I want to get all that Gatorade powder to dissolve. It's pretty concentrated, so it's going to take a little bit of effort to get it fully dissolved. And once we get it dissolved, then we're going to add the rest of the water to get it all the way back up to 100 milliliters. We wanted to make 100 milliliters of the solution, and we put in less than 100 milliliters of water initially, and now I'm going to keep adding it until it gets exactly to the 100 milliliter line. So I'm going to pour water in, and then when it starts getting closer to that line, it's getting kind of close, so I'm going to use a pipette, and I'm just going to add until it gets exactly to that line. A few more drops. That's pretty good. So now we have exactly 100 milliliters of solution, and it has exactly 16.33 grams of Gatorade in it, and you can use that to calculate the molarity of this really concentrated Gatorade. You'll just take the 16.33 grams, change that into moles, and then put that over the volume, which is 100 milliliters. You'll need to, of course, convert that into liters. All right, so we've got a really concentrated sample of Gatorade here. And now we're going to make a series of dilutions. And so we're diluting it so that we have 4 different solutions that we can compare it to. And so what I'm going to do is in the first one, I'm going to take just 2 milliliters of Gatorade, so just a really small amount of Gatorade. That's a really small amount of Gatorade. And then I'm going to add to that 30 milliliters of water. So 30 milliliters of water, that's 10. That's 20. And that is 30 milliliters of water. All right, so we can find the concentration of this diluted Gatorade using the formula M1V1 is equal to M2V2. We know the concentration of this original, really highly concentrated Gatorade, and then this was diluted with just 2 milliliters of that really concentrated Gatorade. We added 30 milliliters of water to it, so it has a total volume of 32 milliliters. All right, and we're going to make a couple more dilutions here. We need several different samples so we can make a graph. So the next one's going to have 3 milliliters of Gatorade. So there's 3 milliliters of Gatorade, and then to that I'm going to add 20 milliliters of water. So here's 10, and here is 20 milliliters of water. So you can see that this one has a little bit darker color to it because it has a little bit higher concentration, and that's good. Our next one, we're doing 4 milliliters of Gatorade. So 4 milliliters of this really concentrated Gatorade. And that is going to be with 10 milliliters of water. And then again, you're going to be using M1V1 equals M2V2 to calculate the concentration of each one of these concentrated solutions. And then the last one is going to be 10 milliliters of Gatorade. With 10 milliliters of water. All right, so we've got a series of dilutions here, and you can probably see that the color varies, right? This one is the lowest concentration, so it has the lightest color. It's absorbing the smallest amount of light. And then this one is the darkest. It's absorbing the most light. All right, so now we're going to take some samples of this Gatorade and put it into our colorimeter. So we've got these to put our Gatorade into. All right, so I'm just going to take a sample of each Gatorade. I'm not diluting it anymore, and I'm just filling it into these small containers that will fit into our colorimeter. So that's the low concentration one. And then here's the next. And the next one. And then our most concentrated sample. All right, so we can get these out of the way. We don't need these anymore. So I'm just putting the tops on. This is the low concentration. You can kind of see that it's the lightest color. And then going to higher and higher concentrations. And then this is our unknown Gatorade. So we can kind of compare our unknown sample of Gatorade. Let's see, it looks a little bit, it doesn't look as dark as this one, so it's probably a lower concentration than this one. It looks darker than this one, so it's somewhere in the middle, right? It's maybe somewhere in here is the range of molarities for this unknown sample. But we're going to actually measure that. We're not going to just use our eyes. We're going to use this instrument, the colorimeter. And so I've got this set up and hooked up to the phone so that I can see the data here. And so I'm going to put in one of these samples. We'll start with the most concentrated one. All right, so we've got it in there. And we're going to see how much light is absorbed. We'll start with seeing how much red light is absorbed. So this thing can check different colors of light. And so I'm going to start it. And we get the red absorbance right here. So 0.124. That's how much of the red light is being absorbed. So there's a red light on one side of this. It's passing through the Gatorade solution over to the other side. So you need to record this in your data table to show the absorbance of red light is 0.124. Okay, now I'm going to switch it. I'm going to look at a different color of light. Let's look at the absorbance of the orange light. Okay, so we just switched it to the absorbance of orange light, and there is 0.237 is the absorbance of the orange light. What we're doing right now is trying to figure out what color light is going to be best at being absorbed by the red Gatorade. And so far the orange is a little bit better at being absorbed than the red. Let's switch it again. Let's try green. Green, we got a higher number here. 0.718 is the absorbance of green light by this Gatorade solution. And then we'll try one more color here. We have blue. We can see the blue absorbance is 3.0. So blue light seems to be the absorbed the most by this Gatorade solution. All right, so that means that for the rest of our experiment, we're going to be using blue light for the rest of our experiment. So that was 3.0 for the most concentrated Gatorade solution. So in the second data table there, where you're recording the absorbance of the diluted solutions, the most diluted solutions, when we put 10 milliliters of Gatorade and 10 milliliters of water, that had an absorbance of 3.0 for the blue light. And we're going to use blue light for the rest of these. I'm not going to keep switching it around. So I'll put the next one in. This is the little bit lower concentration. This is the one with 4 milliliters of Gatorade and 10 milliliters of water. And here is its absorbance, 2.055. Oh, we just switched. 2.106. Okay, so we'll record that. That is for the one that's 4 milliliters of Gatorade and 10 milliliters of water. We'll do the next one. 0.908, right? So the absorbance is decreasing because less light is being absorbed as there's less concentration of the Gatorade powder. And then our lowest concentration should have the lowest absorbance, and it does. It is 0.358. So 0.358, that's the absorbance of how much light is being absorbed. When you shine blue light through that low concentration solution, that's how much is being absorbed. Okay, so you should have those numbers in your data table. And you're going to use these 4 standard solutions to make a graph. The graph is going to have, along your x-axis, it's going to have the molarity, and then along your y-axis, you're going to have the absorbance. And you should see that it increases. As you have a higher molarity, you have more light being absorbed. So we make our graph with our 4 standard solutions, draw those 4 points, draw a line of best fit, and then we're going to measure one more. We're going to measure the unknown Gatorade solution, and our whole purpose of this lab was to figure out what's the concentration of this unknown. We think it's somewhere here in the middle because its color seems to be somewhere in the middle there. And when we measure the absorbance, we get 0.5 or 1.517. 1.517. And so yeah, that's somewhere in the middle. You're going to find that on the y-axis of your graph, and then use that to find the molarity of this unknown solution based on your graph. So that should be all the data that you need. This is using Beer's law, and I think that's it.